wrote on the
So
board.
have you heard about, remember the transversal thing?
Is that marked with what you know?
Yes, it is.
You know what you need to show.
Copy that one instead. Okay, so this and this are the same because it's side, it's side. No, we can't. Can we prove that this is? Can we prove that this and this are the same length though?
Does that say it's side?
Well,
or
that's what we
say
were.
something else.
Oh, side angle.
Yeah, side. Because look,
Yeah.
see right there.
So, and you can prove for all four of them. So,
Are all four of them congruent triangles?
yeah, because side angle side and for this and side angle side for this, and these two are the exact same.
But do all those match up?
No, I don't think these ones do. This one and this one. This one and that one. Yeah. Would be because
Why wouldn't this work then?
even if it did work, it would be different from this one because it's two different ones.
But what are you trying to say exactly? Are you saying that I have them marked congruent? Because I didn't change it yet.
So when you say side angle side, what does that mean? I know that you go side angle side, but what does that mean?
It means that if you have a set of
two triangles,
and
It proves congruency.
that's what I meant. It proves
It proves
congruency.
congruency.
of the whole triangle, but how does that match up? When we just say side angle side, what are we saying?
When you have a side angle side, and that proves that the triangle is like this. Like it's just gonna be like this always if it has the same side angle side. And since this has side angle side also, that proves that they're missing.
It has side angle side also.
Sorry.
Meaning that every triangle, two different triangles. This triangle, and this triangle. This triangle has a side, an angle, and a side. This triangle has a side, an angle, and a side. Does that mean that these two are congruent?
Well, what I meant by that, I didn't say this, but what I meant was that they have the same angle and the same side.
Okay. So my question is, does this triangle here, you said that this and this are the same, but do they all have the same parts that are exactly the same?
This angle is bigger than this one.
I know, I'm not talking about these two though.
Oh, I thought you were.
No, I'm talking about this and this.
Okay.
Oh, okay. That's what I saw.
Yeah.
Talking about I thought
I
thought at one time I heard that all four were congruent. But
Oh, no.
I think you said that too.
That's not what I was trying to prove. It's just, I think you guys are getting confused because I had a congruency mark of 1 for all four sides.
so are they all all four sides?
No, I was just doing that. I didn't change it yet, but I'll change it right now. Okay.
Are all four of those sides of that parallelogram equal in length?
No.
And what did you mark them with?
I did 3, 3, 4, and 4.
Oh, I'm sorry.
Yeah.
Great, thank you.
You could measure, that's for sure, that's true. And if you measured, you'd have an example of exactly one particular parallelogram. What you're trying to do is show that no matter what angle it is, if it fits those criteria, if it fits those 3 criteria, then it's a parallelogram. So what else do you know about parallel lines? What else besides...
They don't intersect.
So have you heard about, remember the transversal thing and those angles? Okay, would you refresh your memories about that? Because if you know what you need to show for parallel lines, you can kind of work backwards from there. All right?
Transversal, right? So it would be,
I'm going to go get a scratch paper.
So transversal is when the lines are parallel, right?
Yeah.
So it's like this, right? So, and then you have a line that intersects it, right?
Or in the case of the parallelogram.
Or it'd be like that, yeah. So let me do it that way, because then we could definitely get...
And with that transversal, it's
the opposite alternate interior angles are congruent, and the alternate exterior angles are congruent, the corresponding angles are congruent, and
But pretty much you only need the
the alternate interior angles, exactly. But you know what? Rough sketch doesn't have to be great, right? So it means this angle would be equal to this angle, and this angle would be equal to this angle, right? So,
that's what it says.
So from this we get that a function of both pairs of opposite sides of parallel, the opposite sides of parallel are equal, and the opposite angles are equal. Yeah. So we have that the opposite angles are equal, right? The opposite angles are equal. The opposite sides of parallel are equal. Well, they have to be. I mean, you guys want to prove it? But they kind of have to be, because distance between this and distance between this would be the same. And this distance can only be the same because these angles are set, right? Yeah. These angles are set. So this equals this. So we got 2. There's 1 more. Where's quadrilateral? Both pairs are equal. And the opposite sides. Wait. Opposite sides parallel. Okay, so both pairs of opposite sides are parallel and equal. Okay, and the opposite angles are equal. We got the angles part down, but I want to prove the opposite sides part. Like, how can we prove it? Can we prove it using transversals?
You have 2 triangles.
Because transversals we can only prove angles, right? So how do we prove the angles? Well, we did prove the angles with the alternate interior angle conjecture.
We can't prove sides.
Wait, what if we had triangles? Like, remember that we could like this, where we have angles that are congruent, the vertical angles are congruent.
Then we had side on one of those, and
then you have it as oh, that makes sense. Remember? That makes sense. So, same thing, right? So, and this would produce a triangle, and you have angle, and these angles, right? Well, you know the basics, right? So, yeah, I know, I get it. So, and then SSS, no, it wouldn't be SSS conjecture. It would be,
but it can be AA.
It wouldn't be AA. Remember when we had that one problem when it was like a giant triangle, and then the giant triangle was cut into, so it was like this, guys? It was like this, right? Remember? And it was like kind of like this.
Yeah.
It was like this, I think. Yeah. Remember that? What was the conjecture that proved that? Remember? Didn't this solve this?
I thought one time I heard that.
It's like the same thing.
It is the same thing. What is it?
Wasn't it on SSS? It was SSS because you had to mark the things. Because they gave you the info and you had to mark each one.
Yeah, and then the only info we have here is that. So, no, but the only thing we have are angles. 2 sets of angles.
Remember,
and then AAA doesn't work.
We do have sides.
Why?
Are all 4 of those
This
sides
one is
parallel?
this one. And
Oh yeah,
this one
because
is
the angles.
This one.
You want to mark
That's the midpoint. This diagonal. That's the midpoint. That diagonal.
Oh, yes, that's cool.
ASA.
So now we have sides.
Oh, now we have
ASA.
ASA. So it proves triangle conjecture. So this is equal to this, which means that this is equal to this. And that's equal to